Okay, today we're going to talk about exploring exponential models, and although the one that we're going to focus on today is y equals x, or 2 to the x power, that is a parent graph, but so are all of these over here, right? All these are also parent graphs. So when you change the base, you just change the parent graph. You really don't change, like there's no transformation happening. We're going to be focusing on key points. So this point will be 0, 1 that's if there's nothing multiplied by, there's no stretch, no compression, right? And this one will be 1, whatever the base is, and this one right here is going to be -1 and then 1 over b. Okay, so I'm really interested mostly on these two, right? Those are the ones that I really want you to focus on. Okay, and as you see this, you can see like there's an asymptote that goes along the x-axis as long as we haven't moved it up or down. Okay, so first we're going to talk about what would happen if we went 2 units to the right. So 2 units to the right means we're going in the x direction. And so we would go y equals, our base would be the same, but then we're going right or left, so we're going to be related to x. And when we're related to x, we're doing the opposite of what we want. So this would be x minus 2. So we would just take that whole graph, this whole graph here on the top, and go 2 units to the right, which means we're changing the x. So if we take the 0 and go 2 units to the right, we're at 2, whatever, or 2, 1, right? And then we take the next one, which is 1, b, and we're going to now be at 3, b, and our b is actually 2, because this is our base, right? Okay. Okay, so let's try and erase these things just because we got way too much traffic. Okay, now let's go to the next one. This one will go 3 units to the left. So now we're going the opposite direction. So this is going to be same base and then x plus 3. So our original one will go 3 units to the left. So this will go 0 minus 3 is -3. And then we'll still be at 1. And then this one will also go 3 units to the left. And so we're at 1, and so we'll be at -2, our base. All right. Now, you guys can always pause this at any time and do these problems and then double check. Now we're going to take the whole thing and move it up 4 units. So we're going to take our outputs, which are this, and we're going to go up 4. So we're going to be adding 4, which means we're changing the y. So when we take this point and we go up 4, it's no longer at 1, it's going to be at 4. So 0, up 4 means 0, 5. Okay? And we're going to take this one and move it up 4. So we're going to still be at 1, but we're going to be at up 4, which is, we start at b, so that's 2 plus 4 is 6. This one would be our 2, our base, plus 4. Okay. Now we'll look at our next one, which will be 5 units down. Similarly, instead of going up, we're going down. So we take all of our outputs and we move them down 5. And so we're going to take this point right here and move it down 5. So now that's going to be at 0, -4. We'll take this point right here and we're going to still be at 1, but we're going to take our base minus 5. So this is going to be at -3. And that's how we got that, base minus 5. Because that was the original output. Okay, let's look at another one. We're going to reflect the x-axis, and that's when we're going to take all of our outputs and make them opposite. So our original output is 2 to the x, and we're going to take all of our outputs and make them opposite. So still my input, but my output, which was 1 at the beginning, is now -1. My still input is 1. My output was 2, so my output is now -2, right? We're going to do the opposite of B. So this guy right here is going to be the opposite of B, because that was our original output was B, and now it's the opposite of B. Okay, let's talk about reflecting the y-axis. Now we're going to do 2, and then we're going to go the opposite of x. So obviously, if I'm reflecting the y-axis, this guy is still the same. We haven't really changed the x at all, right? But this one here, our x is now -1 to give us our 2. So we're just taking the opposite of the input, right? Now, when we stretch, you guys, it doesn't really say stretch what. So when we stretch, there's a number in front. So let's do this one. Y equals 3 times 2 to the x. Okay, so that's the one we're going to be talking about. We're going to stretch 3. Okay, so if I was doing y equals 3 times 2 to the x, then we are going to we're going to multiply all of our outputs by 3. So this would have still had an input of 0, but what used to be 1 is now 3. And this one would still have an input of 1, but what used to be 2 is now 6. So this is made by taking our base times 3, because it used to be just the base. Okay, now let's do 2 things. We're going to go up 1. So we take our original, and we go up 1. So that means this is going to be +1. And we go to the right 3, which means that this is going to be x minus 3. Okay, so we went up 1. So let's talk about where were we originally. We were at 0, 1, and then 1, 2, right? So what we're going to do here is we're going to go to the right 3. So now this is at 3, and we're going to go up 1. So this is going to be at 2. And then to the right 3. So this is going to be at 4. And then up 1. So this is going to be at 3. So you can see how we just took this and added 3. We took this and we added 1 for the up 1. We took this and we added 3. We took this and we added 1. So hopefully you can see how our key points would go. Okay, so how can we write this using a different base? Well, you guys, anytime you have a negative exponent, so like if I had 3 to the -1 power, this is 1 over 3 to the +1 power, right? So that's how negative exponents work. So we can go y equals, and then we can do 1/2, right, to the x power. Because I'm taking the 2 and moving it to the bottom. That's what this negative is going to do. Okay, and so when we do that, you guys, now we have done the opposite of x, which means now we're going to be going this way. And that's called a decay, because it's decreasing. Whereas this original one from up here is going up, so this is going to be called a growth. So when our base is greater than 1, it's going to be a growth. And when our base is less than 1 or greater than 0, it's going to be a decay, or going down. And so now it's time for you guys to put what your takeaways for your lesson are. Okay, take care.